with everybody, if I ask you to work through one or two of these, would you mind doing that? Or
not at all. In fact, first off, let me just say we started our Introduction to Networks recording for this week. I am going to pull up this, which is my frog. Oh, I gotta find. Hold on, let me find my pen. All right, talk to me, Raymond. What do you want me to go through? If you will, Raymond, let's turn the camera off because I'm gonna minimize this and I don't want it popping back up. Okay. Because it takes up screen space.
Well, the first one I'm confused on what I'm supposed to do on 10.101.99.17 CIDR 23.
Okay. So say that for me again.
10.101.
Okay.
.99.
I got a different pen today, folks, so it's making.
.17 CIDR 23.
All right. So, and they're wanting you to find the first usable, and well, they're wanting you to find what network it's on, correct?
Well, you're right. I'm in that lab 7149, Professor.
Okay. And what they're wanting you to do is find what network or what subnet this IP address is on. They're also wanting you to find what the first usable and last usable IP address is.
That's correct.
All right, so let me show you how computers deal with IP addresses. First off, what I'm going to do is I'm going to explain to you that computers are binary. They use ones and zeros. So they are not able to look at this in dotted decimal format like we are. They use a process called ANDing. And what ANDing will be is exactly how a machine determines how it's going to figure out the network it is on, and also the network that any host it tries to send something to is on. So ANDing is a simple mathematical calculation. It pretty much ends up like this. If you got a 0 and a 0, you get a 0. If you got a 1 and a 0, guess what you get? A 0. If you got a 1 and a 1, you get a 1. And a 0 and a 1, you get a 0. Now, here's what I can tell you, and these are each just individual communications or individual items. This way I teach my students, even though mathematically this is not correct, and if anybody sees this on the internet and says that guy's an idiot, he doesn't know what he's talking about. ANDing is not multiplication, but guess what? If you multiply the two numbers by each other, you're going to get the result that ends up being what happens when you AND them. So if you see here, the only way you're ever going to get a 1 is if it's a 1 and a 1 together. Why is this important? Because what is a /23? It's 255 dot what?
254.
254.0. Okay? So when we look at this IP address, or better yet, not us, but when the computer looks at this IP address, in order for the computer to figure out what network it's on, it does the following. It converts all of these octets to binary. Then it ANDs those numbers by the subnet mask configured on that machine, and that will give you the network or subnetwork you are on. So, look at this. Let's take the first octet. What is 10 in binary? 128, 64, 32, 16, 8, 4, 2, 1. That's 10, right?
Yep.
So let's take the mask in the first octet. That's 1, 2, 3, 4, 5, 6, 7, 8. Again, I apologize for the noise. It's the pen that shipped with this thing instead of my Microsoft pen. I'll bring it in next week, next time we do it. Now let's AND these. What's a 1, a 0, and a 1?
0, 1, 1,
0, 0, 0, 1, 0, 1, 0, right?
Yeah.
Guess what fell through? 10. Right? So in the first octet, and by the way, this is, since we ANDed, it's 10. Now let's do the second octet. Let's figure out what's going to be in the second octet when this PC ANDs its IP address by this mask. What is 101 converted?
0, 1, 1, 0, 0, 101, right? That's where I was meant to go. I'm sorry. I would jump to the next octet.
Yeah, I got to do some math here. So that's 96, right?
Mm-hmm. So you can't go. Yeah, you're.
All right, so that's 5. Okay. So 128, 16, 32. All right. 128, 64, 32, 16, 8, 4, 2, 1. That's 101, right?
Yeah.
If you disagree with me, let me know.
Well,
All right. What's the mask in the second octet?
55.
Right?
Yep.
What follows through, folks?
101.
101. So we know in the second octet, the network this host is on is 101. Now here's where it gets interesting. Let's look at this third octet. Okay, now 99 will be 128, 1, 1, that's 96. Okay, so that's 32, 16, 8, 4, 2, 1, that's 99. 96 plus 3. The mask is 1, 2, 3, 4, 5, 6, 7, 8, right?
Yep. So 98.
Exactly. So guess what? This host is on .98 in the third octet.
Not 0 on the network.
Exactly, because what happens if I add 0 to 17? I get 0, right?
Mm-hmm.
So this host with the IP address of 10.101.99.97 is on the subnet 10.101.98.0/23. All right? So what's the first usable IP address?
98.1.
98.1. What's the last usable IP address?
99.254.
Correct. How did you get that?
Because the network is 98 and it's a 254 subnet mask, meaning 99, and the last usable is 254 because 255 is broadcast.
Correct. So what he's saying is this: if you look here and you look at 254 as your mask, 1, 2, 3, 4, 5, 6, 7, 8. Your variable is 2. Okay. So that means it goes from 98 to 99. Actually, you'd think it'd be 80, but I mean 100, but it's 98, 99. So the entire range of this possible is 98.0 to 99.255. And so the first usable, since this, by the way, this is the network ID, actually this is subnetwork ID, and this is the broadcast ID, that means that 98.1 to 99.254 are the usable IP addresses. Does that make sense, Raymond?
I'm not getting it. I'm gonna have to really struggle. I guess I'm gonna have to get it in my brain. I've been using. I sent you, what I did on the other one, and that
one was right. That was correct.
Well, I'm looking at this one where I've got the 254. I got that. I got the seven bits and got the 254.
Okay.
Through my line, and that left me one bit still in the third octet, and then the rest of the past that they're all zeros. Past that, I understand that.
Right. So you understand, Raymond, how we got this subnetwork ID?
I don't see how you got the 98.
Okay, let's go back then.
I see where he's getting confused. I see where he's confused. Where it used to get me, because I store everything out binary-wise.
Okay.
Because, the 99 was a 1, but yet you had a 0, meaning you could take a 0 away, taking that 1 away. That makes it 98. Because to get to 99, you had to have a 1 in that 8 in the 24th slot.
That's
correct.
You
understand? So when you have a 0 there, that means it can change in the subnet mask, meaning it can be a 0. And if you
Correct.
make it a 0, that means you take that 1 away, meaning 98
Correct.
is the only other feasible and possible number you can have. So
Correct.
with the 1 being, since the way I teach it and it stays in my head, is when I got a 255, that means all 8 of my bits, of course, are 1s, so I just call those kind of a locking bit. That means we have locked that. It doesn't matter if above that is a 0 or a 1. What it really comes down to is you can't change that. But when you have a 0 there in that subnet mask on the binary side, which you would with the 254, the 0 was only in the 1's location, the 1 spot. Meaning, you know, to get to 99, you had to use that 1. So that means with the 0 being there, that means it can also be a 0. And when you make it a 0, that means it can be 98. So you're working just with one whole number.
Y'all are making it much harder than it has to be, though. Much, much harder. Guess what? Binary doesn't lie, okay? If you take this, and if you do ANDing, it's going to give you this number. In other words, if you take any IP address, no matter what it is, and you know it's masked, if you AND it to that mask, it's going to give you the subnet or network that it is on. Let me give you a great example. Watch this. Let me make it a little simpler for you. Let's do 192.168.10.10.10/24. Okay? Now, I'm going to leave this over here just for now, just so you got it still. But you can easily tell me what network this is on because it's Class C, but prove it to me. How would you prove this? You know the mask is 255.255.255.0, right?
Yes.
So if I take 192, let's do 1, 2, 3, 4, 5, 6, 7, 8. Let's take 10, 1, 28, 64, 32, 16, 8, 4, 2, 1, 10, 1, 28, 64, 32, 1, 0, 1, 0. Like I said, I wish I had $1 for every 1 or 0 I've ever put on the screen. I'd be rich. And sorry about the noise. Again, that's why I don't like this pen. We'll fix this pen problem. I'll get me a pen in here. I try to be quiet, but guess what? It's not going to make a difference. So I'm just going to go ahead and I'm just going to go for it. All right, so we took the IP address 192.10.10.10/24, and we took the mask associated with that address, and now we're going to AND it. And what happens is you will see what falls out is 8, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 6, 7, 8. 1, 2, 3, 4, 7, 8. What fell out was the IP address 192.10.10.0, which is the network address that this host, okay, so this is a host, this host right here, .10, is on this network. Right there.
I understand that.
And guess what? Every time, if you put this IP address right here, if you put it on a PC, okay, and that PC had to communicate to another PC, even on the same network, what that little happy PC would have to do in order to figure out what network it is on, it would have to do this process right here, which is again called ANDing. Okay? So you see it works for a Class C, simple Class C. It works for all IP addresses. So if you want to know what network that this particular host is on, and you don't even really know, but you just want to know this IP address, you want to know what network it's on and what subnet, all you have to do is the exact same process we just did, but for the IP address that's in that example. Now, for simplicity's sake, and to make your life easier, one thing I can show you pretty easy. If you AND anything to all ones, guess what you're going to get? You're going to get 10.101. We really don't even have to convert that to binary because you know that's going to fall through.
Yeah, that I understand.
Okay, so we take 99. Let's go back again. 99. Let's go. There's, oh crap, sorry. 1 and 1, that's 96. 16, 8, 4, 2, 1. So that's 96 plus 3, so that's 99. And then 17 is 1, 2, 3, 4, 5, 6, 7, 8. There's 17. And our mask is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So what we get to fall through here is 0, 1, 1, 0, 0, 0, 1, 0, dot 0, 0, 0, 0, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. In other words, we get 98 dot 0. So we now know that this host is on, this host right here is on the subnet 10.101.98.0.
Okay.
All right? No different than doing it with a Class C, none whatsoever. You're just anding, and that falls through. Now, this is where it gets confusing, I think is where it gets hard. They ask you what's going to be the first usable IP address. Well, the good news is you know that it's just going to be the first one where there's a 1 in here. So that's the first usable IP address. Okay? And actually, let me do something different here. We know the first usable IP address will be 10.101.98.1. Now the question becomes, how do I find the last usable? And this is where you have to go back to your subnetting and your idea of that magic number. And what you do is, you go and look and see it's 254, right? So what's the last bit position turned on in 254? If it was a mask of 254, and I got to come over here to do this, sorry. 2, 3, 4, 5, 6, 7, 8. What's the position right here? What's the value there? This is 2 to the 0, so what's 2 to the 1 power?
2.
2. 2 to the first power is 2. So you know that this subnet is 2 positions big. So you would think that would mean that it would be .100 on the other side, right? But remember, we go by the first and the last number in there. So it's .98 to .99. So 10.101.99. And then we didn't borrow a thing from the last subnet, so you have to go all the way through. Now the next usable, and actually the usable would be 254. The next usable would be this, 10, and what it is just doing is it's rolling that third octet by 2. The broadcast would be 255, the network would be .0. And see how we're still doing exactly what it says. We are going through and doing our normal subnetting using 2 positions. Because the value is 2 when it's a 254. And so that's how you find your broadcast. Let me show you another way to do it in binary to make your life even a little bit easier. Okay? If we look at this, okay, and we look at our starting IP address of 98.0, and we know that, let me get rid of this, I'm going to get rid of this, I'm going to get rid of, I'm actually get rid of some of this, and let me just try to use my finger. Okay. We know it is 10.101. We know that's going to be there. Okay. We know that 98 is our first. So when we look at this, how many host bits do we have here? Okay. We know it's 254, so we know that our actual network numbers are right here, right? You agree with me?
You have 9 host bits, right?
Correct. But yeah, you have 9 host bits. So if the network number of 10, let me undo this. If the network number of 10.101.98.0, okay, that is when you have all your host bits are zeros, correct?
Right.
Okay. So if I asked you to then find the broadcast ID for this network, what would you do? How could you do that simply? Okay.
All ones.
Exactly. If you were to take this particular setup and you said, okay, I figured out what my network is. I know I've got 9 host bits. Now, I want to know what the broadcast is for this network. I would just change all those to 1s.
Okay.
And what is that value? Now it's 10.101, because that doesn't go away. We haven't done anything to those 2 octets. What is 98 plus 1? 99, right? And if there's all 1s in the final octet, what do you get?
255.
255.
So guess what? You just found out the size of this subnet by doing it in binary. You find out the network it's on, you know that all the host bits are 0s there, and then when all the host bits are 1s, that's the end of the subnet. It can't go any further than that. I didn't mean to write it through there like it do this. Let me change this back. And now you know that that's the broadcast ID. So then you can say, well, guess what? The first usable is 1, the last usable is .254. Does that make sense, Raymond?
Yeah. Yeah, I've got to go back and I've got to play with this ANDing more. I can see that. But yeah.
Okay. What I would suggest you do when you try to do these questions is, number 1, and the IP address to the mask to get the network.
Okay.
Once you have that, take the host bits and turn all the host bits to 1s, and that will give you the broadcast ID for that subnet. So now you know the network ID and you know the broadcast ID. Then it's easy to find the first and last usable IP address.
Okay. All right.
Does that make sense, everybody?
Absolutely.
Yeah, trust me. It's it is not simple, and it is not something that you will be able to gather in just a second. It is a complicated concept, no doubt.
I still write out 128, 64, 32.
Yeah, I do it just to make sure I don't mess up. All right, let's see. Let's do an example. Let's do a quick example. And pull them up. Let's do this. Dang, I'm sorry that's so loud, y'all. I want 60 subnets, not hosts. I want 60 subnets. All the same size, so we're not doing any VLSM, I just want subnet. Take you a couple minutes. I'm going to pause the recording while y'all work on that. If I can find it. Where'd it go? Let's way down here. I go. All right, Nick's back in here, so hopefully he won't be too stupid. Let's make some subnets. So if we want 60 subnets, what would be your first step?
Well, don't you have to identify the number of bits starting from the left, the number of bits to get you to like 24 up to 64?
Up to 64. So what would that be? So you're saying one of the things, we could go through the 7 holy steps since we're doing standard subnet.
Okay.
How many subnets do you need?
60.
How many, I'm not going to write the host bits out, but how many host bits do you have in this particular IP address?
In a host bits?
Yep, how many host bits? In a /8.
Oh, and an 8.
17 host bits.
Now you got 24 to begin with. That's what you got to play with. All right. Now, how many bits are you going to borrow to get 64 subnets?
7.
To the end. 7's a little high, isn't it?
Yes, 6.
It's going to be 6. 2 to the end equals the number of subnets.
Yeah, because we'll end up with the smallest, the most, we can get to 63.
Right. Well, you can do all 64 because, remember, what's 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, 2 to 7. So this is 1, 2, 4, 8. God, I hate this pen. 16, we got to get that another pen. 32, 64, and 128. So we're going to actually borrow 6 bits. So 2 to the 6 equals 64, and that'll be, well, actually, we now turn on those bits, so we're going to turn on 6 bits. We know the first are already turned on, so we're only working in the last 3 octets. So 1, 2, 3, 4, 5, 6, 7, 8, and then we didn't do a thing with the other octet, so 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Got 1, 2, 3, 4, 5, 6, 7, 8. So now we find the highest order bit turned on, which is here. 1, 2, the value there is 4. So our variable we know now is 4. Or our magic number, some people call it the magic number, whatever you want to call it. The first subnet, you always start at 10.0.0.0, you start with the major network number. And you'll notice that our magic number is 4 and it's in the second octet. So 10 dot, what is next?
Well, I kind of went 10.0.
Oh no! Oh no!
We wanted 60 subnets, so I didn't hit the second.
Well, notice I only borrowed 6 bits, so I quit borrowing inside of that second octet.
Right now, I'm confused. Wait a minute.
There's your first subnet. You did not borrow anything. You didn't borrow anything at all from the third and fourth octet. So its value goes completely from 0 to 255. You borrowed from the third octet, and in that octet, you'll notice that the variable is 4. So our subnets are this. As we continue on here, you'll notice, and it would be down until I had 64 different subnets. See what I'm doing?
Mm-hmm.
So I did the variable in the second octet was 4, but there's no other variable in the other octets because I didn't borrow past any other octet boundaries. What's the new subnet mask? It was 255.0.0.0. What is it now?
Oh, 2, yeah.
Yep, and it'd be 8, 9, 10, 11, 12, 13, 14, /14. That's the new slash notation. Anybody know what the last subnet would be? Absolute last subnet? It's going to start with what the mask is. Because notice it's 255, 255, 255. So basically from subnet 0 to subnet 64, 63, really, but it'd be really 64 subnet. There'll be all those through there. And obviously I left a bunch out. But because we borrowed from the second octet, we're rolling that second octet by the variable we had in that octet. That must have caused some confusion. Let's try again then. Let's try again. Let's try another one. Because standard subnet, you got to understand standard subnet didn't do BLSM. So let's do 10.0.0.0/8. But let's do 1,000 subnets. 1,000 subnets.
We're just having lots of fun here today, aren't we?
Oh yeah. I try to make things interesting. Try to keep you on your toes. This is subnetting is the most important thing in this entire course. By far.
1,000 subnets. How many hosts?
I'm not asking hosts. I just want 1,000 subnets. subnets.
Okay.
If I do host, we'd have to go at it a different way. Or if I ask you for the number of hosts. So when we look at this, folks, let me ask you this. How many bits you got to borrow to get 1,000 subnets? God, I hate this pen. I'll say that one more time and I'm probably going to shoot me. How many I got to do?
10?
10 subnets. So 2 to the 10th power equals what?
1024?
Yep. So now we've got, if we look at this particular network, it's got 24 host bits when it's a /8, but we're going to borrow 10 of them. So let's turn on 10. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. Okay? So what's our new mask when we borrow 10 bits? We know it's 255.0.0.0, but when we borrow 10, what does it become? What does this equal? What does this equal in binary or in decimal?
255.
Right? What does this equal in decimal?
192.
192, and then this is 0, right?
Correct.
So your new mask is 255.255.192.0. Now, what you have to do is you now have to find the variable in each octet. So in the second octet, what's your variable? One, because it's 2 to the 0 power. What's your variable in the third octet?
64.
Yep. Okay. So now we're going to make our subnets. We've got to start with 10.0.0.0 because that's the beginning network, right? Now let me ask you a question. Can you go to 10 without going through 1 through 9? The answer is no. You got to have $9 before you have $10.
Okay.
Same thing here. Before we can roll this octet by 1, we have to go through all the possible permutations for this octet and this octet. So what we're going to do is we're going to say, okay, we can't change the second octet yet because we haven't rolled the third and fourth octet. What's the variable in the third octet? 64, right? All right, so we rolled the third octet by the variable and we rolled the fourth octet by a variable. But we still haven't rolled the third octet by all possible permutations. And by the way, you can do this in binary too. It just becomes to me a little more difficult in binary. What would this one be? 64, right? The variable in the third octet is 64. So let's keep rolling. No pun intended. That was a very bad pun, sorry.
You're fine.
Yeah, I'm punny. All right, so what's 128 plus 64? It'd be 192, but remember, it's one less. So this is 191. Now here's where it gets interesting. Rubber Raggy. What do we do now? What's my next subnet? At this point, as you've seen, we now rolled the third octet by all the possible permutations. Okay? So now we go over to the second octet and we roll it by the possible permutations. So guess what? The value here is 1, right?
Yes.
So now this is the next subnet in the range. And so on and so forth until you have 1,024 subnets. Wow. Yeah, that's, you know what the cool thing is though? It follows the same patterns we've seen before. It's got to be along the bit boundaries. It's got to be along these variables. So your variable is always going to be 1, 2, 4, 8, 16, 32, 64, or 128 for each one of the octets. And again, you can't roll this second octet right here until you've rolled the other octets by their full value. Which is really technically, if you look at it, it's really going from 0 all the way to all ones in that octet. But we just do it with what I call the variable or the magic number. Does that make sense?
Yeah, this one makes sense. I screwed up that last one. For some reason, I decided to just jump a whole octet, leave it in 0. And
Yeah, you just said, I want a class C no matter what he says.
Yeah.
You're going to borrow all those bits. Let me show you something cool. Let me show you something really neat. This is something that I think it's good to go back to so that you don't think. All right, let's just go to this one night. Hold on a second. I don't like using green for my network. 192.168.12.0/24 and give me 60 hosts. 60 subnets. Not hosts. Let's do subnets.
Well, you're back to the 2 to the 6th, aren't you?
Right, 2 to the 6th, which is 64. All right, which means we're going to borrow 6 bits. We only have 80 host bits to play with, right?
Right.
So we're going to turn on 6 of them. 1, 2, 3, 4, 5, 6, 7, 8. All right. What's my new mask? It's not /24 anymore. It's a /30, right? Because we got 24 bits in the mask to begin with, because it's /24 plus these 6.
Right.
So our new mask is 255, 255, 255, 25, what? 2? Yep. What's our variable? It's 4, right?
Right.
So our networks are 0 to 3, 4 to 7, 8 to 11, so on and so forth. I don't even write the first part because the first part's 192.168.12, right? You agree with me on that?
Yeah. Yeah, I didn't realize I was still unmuted.
He's like, I'm muted. All right, now try this. I want you to try this one. And then you'll see how common two subnets for this. How many bits you need to borrow?
When you got to do 2?
Just 2 subnets?
Just 2 subnets. How many bits do you have to borrow? 2 to the n equals number of subnets. Don't forget that. So what power I got to raise 2 to get 2?
You got to get 2 to the second power.
2 to the first power. 2 to the first power is 2.
I thought you had to subtract 2 of.
Nope. That's host bits. That's not network bits.
Okay. All right.
Now I will tell you this, Raymond. If you read some old documentation, you will see some people saying that you do 2 to the n minus 2 for subnets. That's only on old gear that did not support subnet 0. That's no longer true. So if I'm just borrowing 1 bit, I'm going to turn on 1 bit. What's my new mask? /25, right?
Yep.
255, 255.
Let's go down to 128.
And my new subnets are 192.168.12.0 to what? What's my variable now?
128.
128. So this is going to be what? 127,
7
and then 128.
is your next network to 255.
So there's your two subnets. You'll notice again, what I'm trying to show you is, folks, it's either going to be 128 as your variable, 64, 32, 16, 8, 4, 2, or 1. That's never going to change. That's going to be your variable. Questions?
Got to be that, one of those. Okay.
Yeah. Because you've only got 8 bits to play with in each octet. So with IPv4, you don't have a choice. The good news is IPv6 is even easier to subnet. I'll teach you that next week. Are there questions? I'm going to stop recording here in just a second. Are there any questions?
No, I think my brain is sufficiently muddled at this point. Well,